Are you confused, lost, and bored? Well, you should be if you're watching one of my videos. I've been hired to teach you guys Chemistry 101 as fast as I can and as clear as I can. So let's hope this works. First off, you should identify whether the compound is ionic or molecular. Once you identify that, boom, it's Christmas. So let's start with ionic compounds, since those are the most basic out of all of them. And the most basic ionic compound are the univalent ones. Basically, metal, non-metal, wabam, you've got marriage. Although, that's pretty messy, so avoid that. Anyway, look at your first element, that's going to be the metal. Write it down. Next, look at your second element, which is the non-metal. Basically, you want to take ide, I-D-E, you want to add it at the end of that. And if you don't, then you will get everything wrong, you will die. So yeah, make sure you add ide. So, therefore, if you have magnesium oxide, well, actually, I just said it, so magnesium and oxygen. Bam! Hanukkah. So that's basically it. When it comes to writing the compounds in the equation form, basically, you do the symbols, you combine them together, and then you swap the charges. Make sure you swap the charges, or else you will die, get everything wrong, you will fail science, and your parents will scold you. Actually, no, you're dead, so they can't scold you, but whatever. You can also have funky ions with multiple charges. These are called multivalent ions. Basically, the deal with these, they have multiple charges. The charge on the left is the most common, and the one you're probably going to use most. The way to express these charges in a word form is by using Roman numerals. If you watch Star Wars, you will absolutely get this. If you don't, go home, watch it right now. I don't care if your teacher's looking at you funny. Just do it and come back. They're pretty long movies, and don't watch the prequel trilogy. It will poison you. So yeah, don't watch those. But anyway, once you get all of those Roman numerals down, if you have a element that has multiple charges, basically just use the charge that is written on the question. So if it's iron 3, you want to use iron 3 and basically swap the charges using the same method. And basically you backtrack using the same method. So yeah. And now you've got the polyatomic ions. These are the big words you see on your periodic table. You know, the ones that scare the crap out of you. And you start trembling. And then there's a person sitting next to you that you really like, and then they start trembling and getting freaked out, and you'll never be able to date them, and then firefighters have to come in and bring you out. So yeah, it's a big mess, but don't worry, I'm going to coach you through this so that you can get a date. Basically, they're really, really simple once you get used to them. All of them have negative charges, except for ammonium, because ammonium's all special and all that. These behave the same way as the nonmetals for the ionic compounds. Basically, you write them the same way, you swap the charges, everything is all cool, except if you are dealing with the multivalent ions, you know, the ones where you have to use the Roman numerals. Basically, you have to put the polyatomic ones in brackets, or else everything is going to get really, really messy. You don't want messy, you don't want failure, so then, boom, you have Kwanzaa. I don't even know what Kwanzaa is. Does anyone know? Anyway, let's go to no, not yet, we still have some more. Now we have acids and bases, and don't worry, they're really simple. Well, bases are, that's why I'm starting out with them. Bases are just compounds, ionic compounds, remember, we're still with ionic. They end with OH-, and if you look at your big scary chart, that equals hydroxide. So anything that ends with hydroxide, that is a base. So, pretty simple, and I'm happy. I'm not happy about acids. Acids suck. Basically, they're ionic compounds beginning with H+, or ending with COOH. Remember, COOH. I could say that a bunch of times. Okay, I'm getting ahead of myself. So yeah, since there's an H in front, that obviously means hydrogen. So they all have hydrogen in them, and there's a special way of naming them. So, if you've got hydrogen blank-ide, so anything that ends with ide, like chloride, for an example, so you have hydrogen chloride, for an acid, that equals hydroblank-ic acid. So therefore, in our example, hydrochloric acid. So yeah, that's pretty simple, and there's also written parts to this in case I'm stupid. So yeah. Next, you've got ones that end with ate, so hydrogen blank-ate, or, using my example, hydrogen sulfate, using those polyatomic ions. You know, polyatomic, okay. So hydrogen sulfate equals blank-ic acid. So therefore, sulfuric acid. Pretty simple, pretty simple. Now you've got the third and final one, which is hydrogen blank-ite. So anything that ends with ite, again, those polyatomic ions. So for our example, hydrogen nitrite. Now you Fast and Furious fans are really going to love this. That equals nitrous acid. So blank-us acid. Ends with us, acid. So nitrous acid. Woo! Goodbye, Paul Walker. I'm going to miss you, buddy. So yeah, those are acids and bases. Now we're going to molecular. Molecular compounds are really, really funny because they don't have any metals at all. They're only non-metals. So yeah, that's really cool. They're only at the right of the staircase, all of the elements in this. You see that staircase on your periodic table? If you don't, you are blind, you are Daredevil. I love Daredevil. I hate Ben Affleck. Why the heck? Okay, I'm getting ahead of myself. Anyway, the elements in this section have a specialty. They end with 2. So, O2, N2, F2, H2, me too? No, that's stupid. I hate that joke. Anyway, the only exceptions to this rule are sulfur and phosphorus and carbon. So, S8, P4, and C, because carbon is so damn special. Anyway, the noble gases don't have any business in your equations whatsoever, mostly because they're so boring and don't react to anything, and they're, well, noble, obviously. So yeah, just ignore the noble gases. there are also some common names that you should know by their, well, common names. Like, for an example, C6H12O6. If any of you have done the plant unit, that's quite obviously sugar, and, more specifically, glucose. H2O is obviously water as well. So, put those answers down, don't put the naming rules you'll see in the next few seconds. If you know the common name, put the common name. Anyway, if you don't know the common name, follow this method, which is using prefixes, like di, tri, and tetra. Now, di, tri, and tetra, for an example, is 2, 3, and 4. So, mono is 1, 2 is di, 3 is tri, and so on and so forth. You should know them, but for an example, I have an equation right here, P2S5, so that's phosphorus and sulfur. So if you have phosphorus and sulfur, and you have a 2 and a 5, the 2 is next to the P, so that means it is diphosphorus. Now, the 5 is next to the S, so that means it's pentasulfide. You follow the same naming rules for ionic compounds as well. You always add the "ide," always, or else you will fail, and you will I've already explained that. So yeah, those are the basic ones. I'll have them written on the screen probably. If I don't, I'm lazy, and I'm busy. I'm sorry. I am trying. I had a weekend to anyway. So basically, those are molecular compounds. Those are ionic compounds. Hopefully, I've explained the rules enough. I've done so many takes for this. I am tired. I want to go to bed. So, those are naming compounds for you. That is Chemistry 101 with Sean Reimer. Thank you very much for watching, and I hope to never see you again.